Hello folks, welcome to the third class of time, space, distance in the basics to advanced series. Feel free to visit the previous two classes to get a better understanding about it, because this class we are going to do something called races. So races is a beautiful idea yet challenging at the same time. So to cover the basics, we'll talk about head starts, we'll get an understanding about linear tracks and then circular tracks. We'll solve a couple of questions and establish our fundamentals strongly. So to begin with, head starts. What are head starts now? Now we have seen this head start word in a lot of places. One place that I can very well remember is this game called Subway Surfer or Temple Run for the Fat. So in the beginning of the game, there is a push button. The moment you click that, you advance a certain distance without running. You don't have to do anything. It will run a certain distance for you, right? That's called a head start. In fact, there is an achievement that says use 5 head starts, use 6 head starts. There's a challenge that you also get it. So what is a head start? The moment you get this example, you understand, hey, head start seems like an advantage. That's exactly what it is. So what is a head start? A head start is something that is given as an advantage. You can get a head start or you can give a head start. So how can you give a head start when it comes to a race? Think about two people running a race. And then let's say A is giving B a head start. So A is giving B an advantage. How can A give B an advantage? Now we cannot think about that. Okay, A is running at a slower speed. Now we have said this over and again. When it comes to time, speed, distance, it's a constant speed. We assume, we understand, if A runs at 10 meters per second, the speed will be 10 meters per second throughout the race, unless or until the question says otherwise. We understand, we take it to be a constant speed throughout the distance. Now you cannot say, okay, A's usual speed is 10 meters per second. Today he is giving an advantage to B by running at only 8 meters per second. You will account for this only when the question says. But in a very generic note, head starts happen in two ways. One, head starts by distance, and then head start by time. Nothing fancy. There's nothing complicated in this idea. Head start by distance. What do you mean by head start by distance? You allow the other person not run a certain distance. You are giving the other person a distance advantage by not making them run a certain distance. Imagine this like a father running a race with the son. What will they do? They'll keep the son a little ahead of them so that they get an advantage, they get a boost. That's the distance. That's head start by distance. If there is a distance of 100 meters, A starts here, B starts here. If this is the entire thing is 100, let's say this is 20, we say that A gives a head start of 20 meters or B received a head start of 20 meters. That's all. That's called as head start by distance. And then there is something called head start by time. What is head start by time? Nothing fancy. You are giving an advantage of time. What do you mean by this? You let the person run ahead of you, right? You let the person run ahead of you in time, very specifically. For example, the race starts, B starts running, 5 seconds later A starts running. That means A is giving B a head start of 5 seconds, or B received a head start of 5 seconds. Head start or start. Sometimes people will say, or questions will say, B got a start of 5 seconds, which means B got a head start. So advantage again. Now the one important thing that we need to remember is, when someone is getting a head start by distance, the standard understanding is that they both start at the same time. If A starts, A and B will start at the same time but at different points. When it is head start by time, A and B will start from the same point but different times. Only when the question says A gives a head start by 10 meters and 2 seconds, which means he's making him stand 10 meters ahead and then starts running only after 2 seconds. The question has to say it. Otherwise, when you hear a question, A got a head start of 10 meters, we say that A and B started running together, but A ran 10 meters short. That's all. So don't confuse, okay, will they start running the same time or different times? In head start by distance, they start running from the same time. Head start by time, they start running from the same distance. There's nothing called head start by speed. Unless the question says A decides to reduce the speed to give B an advantage. Unless you hear that, there's nothing called head start by speed in the questions. It doesn't happen that often. Now there's one word that you might frequently see in racers questions, that's called as dead heat. What is a dead heat? Simply means draw, which means that both the people reach the finishing point at the same time. Now both of them starting, when A is here, B is also here at the same time. That's called as dead heat. It's a draw. No one finished ahead of the other person. You will hear the question say, when A gives B a head start of 20 meters, the race ends in a dead heat, which means that they both reach the finishing point in the same time. It doesn't matter where they started, when they started, but they finished the race at the same time, at the same point. That's what dead heat means. We'll see this. We'll apply these ideas extensively to get an understanding. But then before we solve questions, let's also get an idea about circular races, circular tracks, because circular tracks are tricky. It's fun. The parallel is also tricky. I like circular tracks only when they are simple. Sometimes you can complicate it. The understanding the layers attached to it can make it a little weird. So get the funda proper, understand what are the cases that exist, what type of questions is being asked, and then we'll work with it. So what do you mean by circular tracks? No prizes for guessing. It's a circle, not necessarily a circle. Anything where your starting point and your ending point is same, it's a circular track. Formula races, a lot of things happen to be circular tracks. You start from a point, you go to the same point, that's your finish. Get this. So this is your start. This is your start. This is your finish. And this one complete round, from start to finish, you do it one. It's called a lap. You all know this word. It's called a lap. Get this. Now, both of them, A and B, let's say, start from the same point. Again, here also there can be head starts. There can be people starting from different points. We'll get that. Now, A and B starting from the same point. Now, if they run, what is the first question that you will ask? Which direction are they running? Now, they both can be running in the same direction, or they both can be running in the opposite direction. Now, think of this. They keep running over and over and again. They do multiple, infinite laps they do. So, during this entire run, what will definitely happen? What are the things that will happen? We'll go to the basic part. Obviously, we know that they both will meet. They both will meet at some point in time. At some point in the lap, they will meet. Right? It doesn't matter who's faster or who's slower. One thing that you are very certain is they both will meet at the same point at some point in time. When will it happen? Where will it happen? Under what conditions will it happen? Let's have one look at it. Now, when I say, let's do the first case here. The first case and second case happen to be one and the same. A, B. Now, let's say A runs at 10 meters per second. B runs at 8 meters per second. Let's say the lap length is 40 meters. Right. Now, when will they meet for the first time? Where will they meet? Where will they meet for the first time? When will they meet for the first time? Well, we'll address both questions. We'll find it. Now, in this case, after 1 second, where will A be? A will be somewhere here at the 10 meter mark. B will be at the 8 meter mark. 10 meters per second, he comes at 10 meter per mark. B comes at the 8 meter mark. Another 1 second later, A will be at the 20 meter mark. B will be at the 16 meter mark. Third second, A will be here at the 30 meter mark. B will be at the 24 meter mark. Fourth second, A will complete 40 meters. B would have completed only 32 meters. Right? If you notice, in the first second, the gap between them is 2 meters. Right? B is here, A is here, and B lags A by 2 meters. B lags A by A is here, B is here. They lag by 4 meters. And then from here to here, this is B. This is A. This is B. 6 meters gap. This is A. This is B. 8 meters gap. So we understand every second A increases the gap between them as 2 seconds. So in this clockwise direction, it is increasing by 2 seconds, 2 meters. Can I say in the other direction, it is reducing by 2 meters? Or at this point, he has come to 40, 1 lap. B is here. If they keep doing it, A will probably reduce the gap between them, and at some point, A would have completed a round and then come back and met B, right? We get this? One important idea is, when A meets B, A definitely would have completed 1 lap more than B. Exactly 1 lap more than B. Why? This keeps increasing by 2. The moment I bring it back to 40, the gap between A and B is 40. Now 2, 4, 6, 8, 10, 12, 14, 16, 18, the gap between them increases by 2 meters. It keeps increasing. At some point, the gap between them will be 40. What do you mean by 40? 0, because the lap length is 40. So can I say A has to complete 1 lap more than B for them to meet? So what will be the time taken? The time taken will be lap length divided by relative speed. Why S1 minus S2? The gap between them is 2 meters for every second, 10 minus 8. So for them to meet, time taken to meet, is going to be lap length divided by relative speed. The moment you plug it in, you will find out at what time they will meet. If you want to know where they meet for the first time, you have time and then you have speed. Calculate the distance covered by A or B and then divided by the lap. Right? That will tell you from what point they have met. Simple idea. Hang on to this. This is the first basic idea that we need to understand. Now, if the question is, we are running in the opposite direction, is that making it complicated for us? Absolutely not. There's only one change that we are going to make. In that case, time taken will be lap length divided by S1 plus S2. In general, we say time taken is equal to lap length divided by relative speed. Simply lap length by relative speed would be our idea. It depends whether they are running the same direction or opposite direction. That is immaterial. We read the question, we understand that. S1 minus S2 or S1 plus S2, that depends on the question. The moment you get this, there are layers to that. How many distinct points will they meet? What time will they meet? What will be the distance from the starting point? There's a lot of layers to it. To solve all of this, we need to understand this basic idea to go to that idea, right? So we'll apply these simple logics to a few questions and then we'll see where we stand now, right? So we'll do some questions. In a 20-meter race, A gives B a head start of 20 meters. If A and B run at speeds of 10 meters per second and 8 meters per second respectively, who wins the race and by how many meters? So we know that A's speed is 10 meters per second and B's speed will be 8 meters per second. Now, we also know that A runs entire 200 meters, B runs only 180 meters. Why? He gets a head start of 20 meters. A gives B a head start of 20 meters. Now, if A runs the entire race, if A completes the entire race, he would have taken 200 by 10, that will be 20 seconds. If B completes the entire track, he would have taken 180 by 8, 20 by 8 is 2.5, 22.5 seconds. Now clearly we notice that B takes 22.5 seconds, whereas A takes only 20 seconds. Now who wins the race? A wins the race. By how much meters and by how many meters does he win? When A completes, B would have also run for only 20 seconds. Now they both start at the same time. A ran for 20 seconds, which means B also ran for only 20 seconds. So what is the distance covered by him in 20 seconds? That would be 8 into 20. That will be 160 meters. But would the gap between them be 40 meters? When A completes the race, B has completed only 160. Does it mean the gap between them would be 40 meters? No. B has a head start of 20 meters. That means out of the 40 meters, 20 meters also comes at his disposal, which means the gap between them would only be 20 meters. A wins by 20 meters. B loses by 20 or A wins by 20. To understand this in a diagram, now this 20 meters is gone. B did not run this. B started here. He completed 160 meters. That means he has covered an entire distance of 180 meters. Whereas A has covered all 200 meters. Right? So B started from here, ended here. A started from here, ended here. So B has covered 20 meters plus 160, that's 180 meters. That means he loses by 20 meters. But despite getting a 20 meter head start, B loses by 20 meters, and that will be our answer. Right? We'll hop on to the next one now. It says in a 400 meter race, A can run at 20 meters per second and B at 16 meters per second. How much head start should A give B so that both finish the race at the same time? So dead heat. Again, this is what we call it as. Sometimes the race ends in a dead heat. That's what they give you. Now A's speed is 20 meters per second. B's speed is 16 meters per second. Now time taken by A, obviously based on this we know that A is definitely going to win. Now let's understand what would have happened. Time taken by A would be 400 by 20, that will be 20 seconds. Now think about this. A completes the race in 20 seconds and we know that A wins the race. Obviously by the condition A is faster, they both start from the same time. A takes 20 seconds, A would have won, we know it. But what would be the gap between A and B? We can also understand that if A has run for entire 20 seconds, B has also run for only 20 seconds, right? So can we say distance covered by B is equal to speed of B is given as 16 meters per second into 20 seconds, that will be 320 meters. So when A covers 400 meters, B covers only 320 meters. From here we understand that B needs 80 meters head start. Why? Because only when he gets this 80 meters head start, he can start and then run for 20 seconds and reach the finishing line at the same time as A. So that would be 80 meters head start for B. That's our answer. You can solve it this way, or the other logic would be when A covers 400 meters in 20 seconds, the same time B would cover 400 minus X in 16 seconds. 16 meters per second. When A covers 400 meters at 20 meters per second, B covers 400 minus X meters at 16 meters per second. This is time taken by A. This is time taken by B. They both should be equal. Under this condition, we can solve for X. You solve for this X, you will get 5X is equal to 400. X is equal to 80. Simple idea, and we are through. So get the logic, look at the condition, what case is given, and then approach it accordingly. Right? We'll do one more question on circular races to get the funda. On a circular track of 600 meters, A runs at a speed of 12 meters per second. B starts 120 meters ahead of A in the clockwise direction and runs clockwise. So they are saying there's a circle. Let's say if this is the starting point, A is, B is 120 meters ahead of him in the clockwise direction. So from here, I have to take off 120 meters, and somewhere here is going to be B, right, in the clockwise direction and runs clockwise. So B is running in the clockwise direction. Nothing mentioned about A. We find it. If the time taken by A to meet B is the same, whether A runs clockwise or anti-clockwise, find the speed of B. So they're saying that, hey, whether A runs in this direction or this direction, the time taken is same. What does it mean? If both of them run in this direction, the relative speed would be different. In this direction, the relative speed would be different. They will have to cover 480 meters for them to meet in this case. They'll have to cover 120 meters in that case. And they are saying the time taken would be same. Now for A to meet B, what will you say? Time taken is 120 divided by 12 minus x. I'm going to call speed of B as x. So 120 by relative speed, 120, 12 minus x. Let's call this x. But we know that it is as same as 480 divided by 12 plus x. If they run in this direction, they would still meet in the same time. So these two are equal. We'll solve for this one. So this gets cancelled. This is 1, 4. Cross multiply. 48 minus 4x is equal to 12 plus x. Over here and over here. 5x is equal to 36. X is equal to 7.2 meters per second. So B's speed is equal to 7.2 meters per second. And that's it. Again, apply the logic, look for the condition that needs to be applied, plug your values in, plug it in, and then we are through. So that's all the necessary fundamentals that you need to know before you attack some challenging questions, distinct meeting points and all those questions. Get a proper gist of this about this funda, and then we'll be able to solve more questions. We'll see some challenging complex questions in the forthcoming sessions. All the best. In case if you have understood the concept of linear tracks, circular tracks, head starts and everything, try solving this question. Another simple idea, have a look at it, and then do join the Telegram channels if you are looking for the solutions, answers or anything whatever we post here, and drop your answers for this question in the comment box. All the best.